So this is part number 206. Again, this is talking about the space elevator. You want to start with line 18.0 if you're going to go into this detail, okay? There's about 4 videos that I'll explain how to do it. So this line 18p2 Sagnac effect, velocity, light beam, fiber optic, space, elevator, 5G Wow Seti. And there's the alien radio signal. This is the Sagnac effect, also called Sagnac interference, named after the French physicist Georges Sagnac. It is a phenomena encountered in interferometry that is elicited by rotation. The Sagnac effect manifests itself in a setup called ring interferometry. A beam of light is split, and the two beams are made to follow a trajectory in opposite directions. So that's what you want to do with the beam of light. You want one hitting one side of the mirrors and one hitting the other side of the mirrors. To act as a ring, the trajectory must enclose an area. On return to the point of entry, the light is allowed to exit the apparatus in such a way that an interference pattern is obtained. The position of the interference fringes is dependent on the angular velocity of the setup. This arrangement is also called a Sagnac interferometer. So keywords in the quotes from Wikipedia. An optical fiber or optical fiber is a flexible, transparent fiber made of pure glass, silica, not much wider than a human hair. The Sagnac effect, usually several mirrors are used so that the light beams follow a triangular or square trajectory. February 1st, 2000, my thoughts. We're going to use the Sagnac effect to transport your spaceship up into outer space, using the power of light in mirrors along a fiber optic central force. So we have special relativity, we have a mirror, we have a beam splitter with a mirror, screen, a lens, and a laser. And it's ether drift, velocity of light equals c, and number of fringe shift is n equals lv2 over xc2. It's the Michelson-Morley experiment. So you can use this technology with this space elevator. The search was on in the late 19th century for this elusive ether. Finally, in 1887, Michelson and Morley demonstrated conclusively that the speed of light is different in different inertial frames is the same everywhere. The Maxwell's equation in electromagnetism also indicates that the speed of light is a constant regardless of the relative motion of the person measuring that speed. But as just mentioned above, the velocity of light is different in different inertial frame according to Galilean transformation. The theory of special relativity was postulated to reconcile this kind of inconsistency. The theory does away with the idea of absolute frame of reference, such as the ether, and treats all inertial frames on equal footing. So figure 2 is Michelson-Morley experiment. And they show that there. So you want to use this with your space elevator. Okay? Mathematically, if a spherical light wave is generated at the origin of S and S inertial frames, when they are coincided at t equals 0, the statement above the constant velocity of light in different internal frames can be expressed as this. Okay? So, constant speed of light. This situation is possible only when t is not equal to t. It can be shown that the Lorentz transformation below would satisfy the requirement. So here's all the calculations. You can look at them on Wikipedia, okay? Talks about Minkowski space-time, how high energy physics, when velocity of particles is closed, the velocity of light, that comes up. Okay, so that's the end of that video.